Let's see. Okay. Let people stream in here for a bit, and then we'll get moving. So I realized the homework key for this one hadn't been posted before I left town on Thursday, so I made sure it's up. But if you tried to get it earlier, you probably got a 404 link. Nobody complained about it, so I didn't know about it until earlier today. So I'll just take that to mean nobody actually tried to download it. It's now identical to what we did in the lab last time anyway. So you're kind of two options here as we get moving. If you want to set up, is to either continue from your document from last time, which if you followed along in the lab should work perfectly fine. You might want to make sure it knits and everything that it's okay. Your other option is to go on to the course website. 1 second here. Okay. The other thing you can do is go on to, come on, get back to the course website. No, that is a picture of my face. Okay. So you can go on to the course website. And all the way down here, you should see you can use either Homework 6 Part 1 key, which looks like that, or you have, you can click on Homework 6 Part 2 right here. Make sure that's not the right one. Homework 6 Part 2, RMD. No, that one doesn't look updated. That looks like the old one. Let me verify that's the correct one. Nope, not that one. Homework keys, X6 keys, X6 Part 1 key. Yeah, that is the right one there, but okay, sure, there, reloaded and it works. Okay, had a cache from my computer probably. Okay, so you should be able to pull it down from there and get what you want. Okay. So let's go ahead and get moving on this. So basically what you want to do, first of all, to get started is to make sure all your prior code runs from the last one. So the easiest way to do that is to open up a new chunk. So in the actual homework 6, there should be like a blank chunk here in identifying trip regions. If you just go ahead and run this middle button right here that says run all chunks above, you press that, it's going to rerun every chunk above, which should be all of the code we did last time. If you get errors from that, then you might have a problem. And the easiest thing to do is to download the template. But if you didn't get any errors in knitting your homework and turning it in, it should work perfectly fine, assuming you didn't change anything. Okay. The sort of status of the homework as it was left off last time. we should have something that looks like weather data with about 366 rows, 21 columns. We didn't modify any of that. It should just be fine. The only thing we really changed was we made date into an actual date column. And then up here, we should have our trip data. If we glimpse our trip data, we should have about 143,000 rows. And then we should have start time, date time. Stop time is also a date time object. And if we take a quick look at like the short-term pass holders, they should be labeled unknown for gender rather than missing values. And that's basically all we did last time. If somebody's not in that sort of state, you probably want to use the template. Okay. Folks are quiet and invisible today. This is getting near the end of the term. I could just be talking to myself. Who knows? It's a mystery. Nothing new. Okay. So the idea here is for the rest of this one, what we're going to do is we're going to start building out some functions. We're going to build out some functions to perform some quick little tasks for us, and we're going to eventually build a function that draws some plots for us on demand, like the one we did in last Wednesday's lecture. Okay. So as we see in the instructions here, if we look in data list station data and trip data, just quickly pass these to a glimpse. If we look in data list station data, we have entries like this for the terminal. It says terminal BT 01, 03, 4, 5, CBD 13, CBD 03, 07, and so on and so forth. Okay. Well, what these things are in here is the combination of a sort of region code like BT, which is probably Belltown, CBD is the central business district, and so on. So we have a combination of those and then the specific station within that. What we want to do is create a function that when you provide it something that looks like BT01 or CBD03, it extracts only the BT or the CBD. Okay, so we're going to make a quick function that will do that. And you can also see if we look into the trip data instead of the station data, we got the same thing. For trip data, you look here and you'll see from station ID will be like CBD06 or something. To station ID is PS04. Well, these are bike rides that left Central Business District Station number 6 and went to whatever PS04 is. I'm not sure what PS04 is. Okay. What we're interested in, what we're going to plot later, is the flows of bike rides from, say, CBD to PS, regardless of which station it is. There's a whole bunch of CBD stations. All I care is people's flows of rides from CBD to PS. Okay, so if we look at the instructions right here, they all have these 2 or 3 digit character codes followed by a hyphen and a numeric code like CBD11 and ID01. So what we want to do is we're going to write a function called region extract that will extract the region codes. So this function is going to take a character vector as its input, that is a vector of all the region codes, and it will return another character vector whose output is just the initial character codes and not the -11 or -01. Okay. And thus, as an example, if I run code that looks like this with region extract, it should produce for me CBD and ID as an output. Okay, so my example vector, I'm just going to make a, this is how I recommend using building out a function. Start with some example data that you know what it should take as an input, so that you can use as an input and you know what it should produce as an output. So for this, I know my function needs to take CBD-11 and ID01, and it should produce something like CBD and ID. I could even say expected result and actually build a unit test here in a minute. Okay, I'm going to show you how to do in this class, but let's do it. Let's surprise people. Okay, so if I want to write a function that does that, how might I get started with that? This could be either how do I build the scaffolding of a function, or how would this have to operate to produce CBD and ID? Anybody have any ideas? So first of all, if I just want to make a function, what is the function for making functions? Oh, it's function. The function is for making functions. So we're going to get all funky in here and make some functions. So we're going to use function to make functions. And as far as how we do it, that's a great example there. Use a regular expression to find the prefixes and then remove the digits and hyphens after. That's a great strategy. We'll come up with a specific code to do that, but I like that way of attacking it. Let's use some of those regular expressions we picked up last week. Okay, so if I want to use the function to make a function called a region extract, what does that code look like? What would I have to add to this here to use this to make a function called a region extract? Tell me in the abstract. You can write the actual code. So the function makes functions. If I want to create anything in R, how do I typically create something in R, right? It's not specific to a function here. If I want to make something called region extract, it can be anything I want. Yeah, we're going to use an assignment operator, right? Okay. So what's on the left side of the assignment operator? Well, what do we want to name it, right? We're going to say, we're going to name it region extract. Okay. Then typically after a function like this, you'd probably put some of them squiggly brackets and then do some code inside. So Sam suggested as an approach to this, we can use a regular expression to find the prefixes and then remove the digits and the hyphen after. So what I'm going to do is let's write that sort of operation for how that's going to work outside of this region extract function for now, make sure it works, and then figure out how to generalize it and put it inside the function. If what I wanted to do was take my example vector here, which is again, CBD and ID01, what code would I write to just extract CBD and ID from this example vector? Do we know a function we could use to do that? Remember something from last week that might do that? It's about 3 different ways I can think to do it off the top of my head from last week. Do you remember what function would find the prefixes in here and pull them out for us?
Was it the string subset?
String subset would, in this case, what string subset would do is string subset would select it down to individual elements like either CBD or 11 or ID01 that match a pattern. But there's another function that instead of subsetting down to specific elements, it subsets down to small parts of the strings themselves. That is, it pulls out from these individual elements sub-elements. It's not string sub. It'd be awkward to do this with string sub, but there's another one. str underscore. Does everybody remember this one? Used it only once or twice. Do you remember string extract? Yeah. So if you remember how string extract works, if I say, actually, I'll just see if somebody knows how it works. If I say string extract here, you see it says it takes a string and it takes a pattern. Well, for my example, what's the string I'm extracting from? That's the first argument here. Just doing my dumb little toy example here. What are we going to extract some stuff from?
quick question.
Mhm.
Is this or is these string functions under a specific what do you call it? The library
Yeah,
package?
it's in stringer. So if you can't find it, do library stringer and you find it in there. I loaded library stringer earlier to use the string underscore sub function all the way up at the top here. Like way up here, I loaded library stringer right here to use string subset, actually, it looks like. You might not have it in there, in which case library stringer. Yeah, so if you're struggling to find it, might not have the library loaded, and then it's totally understandable. Okay. So yeah, we got stringer loaded up. And if you do library tidyverse, string is one of the packages that gets loaded. Okay, so string extract. So we're going to string extract this vector. The question is, what would be the regular expression I would have to provide to string extract to get either of these codes? So there's 3 letters here. There's 2 letters here. I want, in plain English language, right? What do I want here? I want all the letters that occur before a dash, because that's what every single one of these looks like. Well, how would I get all the letters that occur before a dash? And you can think of any distinguishing characteristics of these that might be useful for subset. Where do the letters always occur inside these codes? They could always come forward from the end. Maybe, probably, but I'm not completely sure. And in fact, you could use a pretty clever string subset using that. using that. So it could be the first 3 or 2, but they always are the first, right? They're always at the beginning. Do you remember how in a regular expression, to tell a regular expression to look at the beginning of a string? Even just what it's called to do that. Did it a couple times on Wednesday. So long ago. So do you remember anchors? There were 2 anchors we introduced. You could anchor to the front of a string, or you could anchor to the back of a string. Do you remember either of them? Yeah, caret was the first one. Asterisk is not an anchor, though. Asterisk is a repeat. So you can put an asterisk after something, and it will repeat the first thing. But the anchor, the first one, the caret is right. So a caret says, start at the beginning of the string. Okay, now we're beginning to start. This will keep us from getting anything at the ends of the string, no matter what, unless we matched everything all the way from the beginning to the end. What's the next thing we want to match? What are CBD and ID, right? What is unique about them that's different from everything else in the string? How does CBD differ from -11? How does ID differ from -01? They're letters, okay? So how would we select a letter in a regular expression? There's a few different ways you can do it. I've mostly showed you a crude way to do it, but that crude way works, and so it's fine. Do you remember that from our address examples from Wednesday? If I wanted to select a bunch of capital letters, any of them, yeah, we could do something like that. So this is something that's sort of like, we're going to construct a little set of things. So sets tend to go in brackets like that. And then you can usually give them a range. You can say something like, well, I want every letter from capital A to capital Z. Well, every letter from capital A to capital Z is every letter that's a capital. So this is a way to select all of them. What is this going to produce right now if I run this line of code? What do we think we're going to get from CBD11 and ID01? I mean, by now you know if you run it. Okay. So what does it match? If you look at this, it says begin at the beginning of a string and then find me any letter. Well, it should produce for me begin at the string, give me any letter and stop. Begin at the string, give me any letter and stop. I ought to get a C and an I because it begins at the string, gives me that first letter, and then it's done matching because I haven't told it to match anything else. So it's like, okay, you just want a C and an I. I can do that. Okay. So if what we want to do is match not one, but any number of letters in a row, right? How could I augment this? I can add one little thing to it. Exactly. That asterisk from earlier will say any number of letters. So it basically says match A to Z, and then just keep trying to match that until you fail to match. It will not match a dash because that's not A through Z. There is a dash here, but this hyphen here is, or dash is being used to signify a set. So it won't. Now, do you see any potential problems with this? Is there any way that A through Z repeated an infinite number of times could ever match a dash or a 1 or a 0 or anything like that? Is there any way that there's a 0, 1, anything like that? Oh, it shouldn't be, because none of those are an A to Z. So we don't have to tell it to stop. We don't have to say stop at a dash or something. Simply by virtue of saying we only want to select A through Z, it's impossible for it to ever get the dash or the 11 or anything like that. Because we've anchored to the beginning, it's never going to get anything like pulling only from the end. There should be any letters there anyway. This very simple function call will produce to us CBD and ID. I could produce some weird example like that. And it's still going to give me only the first characters that come out, no matter what junk I put in there. Okay, even if there's letters over here at the end, they occur at the end, it doesn't match the stuff that precedes it. So even if there was some typing error in here, as long as that dash is still there, we got no problem. Okay, so remove my absurd example. Okay, so now the next thing is this thing right here, this command here, string extract with this expression gives us exactly what we want. How then can I modify it so instead of putting this string extract everywhere we want to use it, we run it instead inside of a function? So if I copy and paste this in here, okay, what things do I need to modify here to make it so region extract can take a vector as an argument and run this on that vector? What do I got to change? There's one thing missing from sort of the scaffold of the function and one thing that has to be changed inside the function. How do I make this flexible? We could add a return function. It's technically not necessary in this case, but let's do it because it's a good practice and good on you for remembering. I can wrap this in a return. This just tells the function very specifically that what I want you to spit out is whatever's inside here. Okay. So what next? So if I run, basically I want to be able to run region extract on my example vector and have it spit out the answer that I want, which is the CBD and ID. Okay. Well, what is this thing that goes in region extract? What do we call this when I put example vector there? So this says add the vector we want to use to the function parentheses and change the example vector to do the same. So do you mean, are you saying add something here? Yeah, that's fine. Your instinct is correct. The things that we generally say, if we want to give something to a function, that thing is usually described as an argument. Exactly what Steven says there. So an argument. You've seen me use it a lot. What is a common argument to give to a function if you want to be lazy? I like one-letter arguments. I always say it's a function of x. This is region extract. It's going to take a single argument. It's some character vector. I'm just going to label it x to look like all those other functions in R. Now, what do I have to change inside of here to make it work for the argument x? So how does it work? The way the function works, right, is I run region extract on something, and it's just going to replace x with the input for everything inside the function. Well, so where do we want that to go?
Does that replace example vector?
Perfect. Exactly. We're going to replace example vector with X. And now what this function does, I've got this little region extract function here. You can see its source code is exactly what we just generated. Now, if I say region extract example vector, it spits out the answer that we want. Because what it's doing is it's running this code in here, return string extract X this, but it's substituting anything I give here as an argument for X. You can even specify it directly and say X equals example vector, if that makes more sense. It's kind of like doing an assignment. So we do that, but it also means that we can give region extract. We could do region extract on our example vector, but we could have other example vectors. I could say vector 2 is something like I'm missing a okay. I could have like example vector 2 here. Nice thing with the function is now I could just apply it to something else, right? So we basically wrapped this in a very simple way. Object X not found. So string extract first regex. So what is your actual code you're running on region extract? So you're just doing region extract example vector. Make sure you run this line up here that generates example vector. And also make sure you've changed this to be a function of X and this to be string extract X. And if not, copy all your code from here down. Function of X, string extract X. Unless that's a capital X, doesn't look like it. Huh? So let's see. Nope, that looks, honestly, I mean, that looks identical. Okay, so make sure you can run example vector and it produces CBD11 and ID. Okay, Mark. Okay. Might have been like, yeah, something like that, run one line of it. Okay. So now we have this little region extract function. And I could also say, for instance, that we know that our region extract on the example vector should produce CBD and ID. So I said CBD and ID. You can do what's called a unit test by basically saying expected result equals the exact same thing as this. This should return expected result on that. This should return trues in both cases. This is essentially a quick way to build a little test. You can even do something like say, if all run a little message to celebrate that you've correctly done your part of the assignment. This is just saying test to see whether the expected result is equal to actually running the function on the example data. Larger scale versions of this are referred to as unit testing in programming speak, and it's sort of just ways to verify you're getting the results you expect when you run a function on like toy or example data. It's good to build in tests in your software if you're working in an actual group. Anyway, it's not important that's there, so I'm going to delete it. So we got this region extract. Okay, so now what I want to do, let's use this little function to perform an actual task. So we go down here, and if we take a look at station data and trip data again, if I look at station data, okay, we got a terminal here, things like BTO1. If I want to change my station data to have a new column in it called terminal region, which has just the extracted station codes from terminal, how might I go about doing that? So we're going to use the function we just built to make a new variable. First things first, if I want to make a new variable, yep, you're ahead of me. If we're going to make a variable, we probably want to mutate. I want to mutate and create a column called terminal region. How would I do that? I want to say mutate. Terminal region. Okay. And if I want to make terminal region equal to extracting the region from the terminal column, what would I do here? So how would we use this function we just created called region extract to make this terminal region variable? Or column, I should say. That looks pretty good to me. We're going to say terminal region is going to be equal to the result of running region extract, right, on the terminal column. Okay, break this into 2 lines. It's a little easier to look at. Okay, now if I run this, I'm going to pipe it into a glimpse just so it's easier to look at. Pipe this into a glimpse. What we've done is we've created a new terminal region column, and the results in terminal region are the same thing up here, but with all of the dash numbers sliced off. So BT01, 3, 4, and 5 are all just BT, 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 BT. CBD 13, 03, and so on. It's all CBD, 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 SLU, CBD, and so on. Okay. So the function we made earlier, which we applied to a toy example of 2 elements, works perfectly fine on 54 elements in our like terminal data or whatever. Okay. So region extract works. If I want to assign this back to the station data, right, I'd have to go like this, add the column in by doing an assignment. Okay. So now our station data has a new terminal region column in it. I'm going to do another chunk here. Now, get an error problem with mutate and put terminal region. Terminal region must be size 54 or 1. Strange error 2. We got the exact same strange error. Must be size 54 or 1, not 2. Well, the reason for that is if we scroll all the way up here, I bet in your region extract function, you still have example vector here, or you don't, but you haven't yet rerun the function itself here. Because what you're actually doing is you're running it on your example vector, which is spitting out a length 2 object. And thus, where it says the input must be size 54 or 1, not 2, that's the only way that could happen. So make sure to rerun this line and then rerun this here. Both of you. And out of curiosity, did you see how I troubleshooted that? I know it was really fast, but the way I troubleshooted it was, it says, for you, it's a bit of a strange error, but notice there's useful information in there. So it's saying, with mutate with input terminal region, X input terminal region can't be recycled to size 54. So the reason is that mutate can only take, will only recycle a length 1 thing to the length of the number of rows. So it accepts only 2 types of argument. Either something that produces exactly 1 item or produces the exact same number of elements as there are rows in the data. In this case, it produced something length 2. And I think to myself, the only length 2 vector we've dealt with is this ridiculous little example we used up here. So, not magic, just logic. Okay, next thing. So, next thing we want to do is in our trip data, we need to take, make 2 new columns. We're going to do a to station region and a from station region. The reason for this is that the trip data begins at a station and goes to another station. There's 2 different sort of regions we're interested in. So to do that, I'm going to grab my trip data. I'll just show you. Glimpse at it real quick. Glimpse at it. We see we've got a from station ID and we got a to station ID. Okay. So same thing here, right? The only difference here is instead of saying terminal region, I need to do a to station region and a from station region. Now you might have the instinct to be like, well, if I'm going to run this function twice, why not use a cross or something? Well, the one reason to not use a cross here is we're not overwriting our old columns. And if you want to use a cross and not overwrite your old columns, you have to give it a special scheme for stitching the names together, which I have not taught you how to do in this class and is difficult enough that I would have to look up the documentation to do it. So if I run into a situation where I can save myself one line of code by doing 5 minutes of reading online, I'm just going to write one more line of code. Okay. So the syntax here. Right? So mutate. Right. This isn't tricky here. I'm not even going to solicit it. It's the exact same code you just do up here. It's one of the nice things about canning your own little functions together. We don't have to write very much. We're literally just going to say, yep, as she suggests right there, the two station region, right, is again, it's just equal to region extract on our, what is it? Station ID, except I can't type to save my life. So there we go. Okay, and then the supreme laziness from station region.
I have a question.
Yeah.
Why, I guess like the region extract pulls out any letters. And then we specified that it had to be capital letters.
Mhm.
These are, so I guess, or never mind. I answered my own question as I was asking it.
Yeah, they just happen to all be capitals. If they weren't all capitals, we'd have to do the lower cases too.
Yeah, I think I originally was confused in thinking that it was making the column names like basically taking off terminal region and taking off the region part and creating just terminal. But now I realize it's actually the values that
Yeah.
it's extracting, not the column name. So
Yeah. Yep. It's just grabbing some text and ripping a little bit off of each element of text. If I run this here, I can scroll over here and we've got like from station ID to station ID of CBD PSO4, the new columns to station region PS from station region CBD. From station CBD, from station CBD. So this is this is almost a silly example because we didn't actually save much typing over just having written the string extract ourselves. But you could imagine if your string extract here had an enormous regular expression, or you also had to do string trimming or padding and other things, you could put all of those inside a single function you create and then just go and use that function over and over later, thus saving you potentially dozens and dozens of lines of code. This is sort of the motivation for writing your own functions. It sort of encapsulates things. This is a very simple example, but you can imagine this scales quite a bit. Okay. So I'm going to assign this back to trip data, run it, make sure nothing breaks. Okay, and now we've got our regions here. Okay, next thing we want to do here, moving on, no questions there, nothing breaking, nothing being weird. Me not moving too fast or anything. Okay, let me know so, or if I missed anything. So next thing we want to do, what we want to do is we want to identify all the rainy days. We're going to.
I have another question.
Oh, that's fine.
In the previous one, should we
Mhm.
also do like reassign it? Oh, I just saw you did that. Okay.
Yeah, this is exactly me potentially moving too fast.
Okay, so we do reassign it back to data list trip data. Wait. The first time you reassigned it to station data, this time you reassigned it to trip data.
Yeah, these columns are in trip data. This column is in station data. So I'm just doing them in the data frames that they're in. We're eventually going to merge these together a little bit later, but for now they're in separate data frames, kind of like our old NYC Flights 13 data. That makes sense? Nothing weird there?
Yeah, that makes sense. Thanks.
Cool beans. Okie dokie. Next thing. So, right, what we're going to do, because we're eventually working up to this thing about what we're going to do is we're going to compare when it's either raining or not raining across the entire span of all the days of the year, what are the flows between like the CBD stations and the Capitol Hill stations or something like that. So we're going to stratify on whether it's raining or not, and we're going to look across like every day of the year and see what are the patterns in travel. Like you'd imagine people probably like to ride bike share bikes a little bit less when it's dumping rain on them, stuff like that. They probably like to ride less in the winter. Also, we're going to look at these things. Okay. So to do that, we need to get some weather information. So I say here, the events column in the weather data mentions if there was rain, thunderstorms, fog, or whatever, and sometimes there are multiple weather events. All we care about is just rain or not. So let's take a look at this and see how we could establish if there's rain or not. So I'm going to go count events. This is a quick way to tabulate and look at just a single column in the data set. So if I look at all the values of the events column in the weather data, we see there's a few different things you can get, right? It can be just foggy. It can be foggy and rainy. It can be just rainy. It can be rainy and snowy, rainy and thunderstorm, or NA. Okay. So if you look at data like this and you see a whole bunch of different weather things and then 205 NAs, we can probably assume that the NA just means there were no events. That is, it was probably a dry day. Okay. So the thing is here is what are the different values here that could be a rainy day that we're interested in? Okay. So which values here indicate rainy days to which we want to assign a variable to have the value rain? And which ones do not have any rain? It's essentially a kind of proper way to go about this, and also kind of a lazy, shitty way to go about it that's also valid for this homework. I will probably say err on the side of the way that would work in other ways. Yeah, you go, okay. So that's the way. It's a shitty way. That's smart though. That shows you thinking. Okay. So you looked at this here and you're like, what is the laziest thing I could possibly do? The laziest thing I could possibly do is say, well, not fog, right? Not fog alone, right? Because everything else contains rain here. But then you have to think about it a little more and be like, yeah, but I also don't want to assign rain to the NAs down here and so on. So yeah, but you basically could do that. Just be like, as long as it's not specifically fog, or if it's NA, then it's rain. Okay. You want to be select to you have to do it with a if we want to filter them, you can filter them down. But instead, what we want is to create a variable. So with those here in mind, being able to see them, and what we want to do, right? It says here, add a column to this data frame. We're going to call that column rain, and it takes the value in text of rain if there was rain and no rain otherwise. Well, creating a column, we know how to do that, right? We know you create columns with mutate. And if I want to call the column rain, I name it rain. Okay. Now the actual legitimately sort of hard way to do this, right? I recommend up here one way you could do it. One way you could do it would be to use string detect, if we remember that from our lecture. Otherwise, we might have to do something else. And also, if you remember how string detect behaves, that might not get you exactly what you want immediately either. So if I want to create a variable and I wanted to take one of two values based on some sort of status or condition, what is a typical function we would use to do that? Yeah, if else. It's one of the most useful and powerful little functions in R. It's a vectorized way to turn a logical statement into some values. So I'm going to say if else. Now, the question is, what logical statement are we going to use? So, right, there's one suggestion was, well, if it's not fog, that'll do. We could think of a way to do that. But how would we do it if we wanted positive selection? Like we wanted to make sure that in case some new rain event was added here, we wouldn't have it mess up, right? So one way to do it is to see immediately, right? Every single one of the ones with rain in it has the word rain. So how might we make this produce for us the value rain if it sees rain and no rain if it doesn't? What logical statement might do that for us? And we could do it, keep in mind, with a function that generates a logical value. Like if we want to use string detect for this, how would we do that? I remember how that works. Well, we can start using it. Let's start with string detect. Okay, let's look at string detect. Can't remember how to use something? Look it up. So string detect the presence or absence of a pattern in a string. So we look down here, it says its syntax is string detect, a string, a pattern, and optionally a negation, which is flip it from true to false. Okay, well, it says it takes a string and it takes a pattern. Well, what string are we looking at? If we want to run string detect, what are we trying to detect stuff in? Yeah, we're looking at events, right? We want to look down every element of events and try to find what? What exactly are we looking for? Yeah, we're looking for rain. So let's see if we can find some rain. So if we say string detect events rain, do we know what this produces? What the output of this function is going to be here?
Would it create a column named rain and just include every event that has the rain in it?
Not exactly. So what I'm going to do is I'm going to cut out the if else for a second and show you what this produces. If I go over here to our new rain column, it's going to have all the values, but it's going to be trues, NAs, trues. Notice how these line up. Rain, it produces a true because it finds rain. Let's see if I can find some other things. Rain, snow produces a true. Fog produces a false. That's what we want. But what's up with the NAs? Do you remember why this is problematic? So what happens when you run a logical statement of some kind on missing data? Shit breaks, right? You can't test to see if something like rain is there if there is nothing there for it to search it. Okay, so our issue here is, okay, string detect events rains works for the actual valid events. It works for all of these here, but it fails when the data are missing. Okay, so there's a couple things we could do here. If I say here now, we put it in if else. So before we fix this NA solution, how could we make this if else return rain when it finds rain and no rain when it doesn't? What do I got to add here? Remember how if else works? Then we'll build it out a little bit more. Now, NA.rm false is it's a good instinct on this being like, well, if missing data is a problem, we want to drop it. But this is actually a case where the missing data is useful. It's informative because NAs aren't really missing. They just mean it's not raining or technically not weather, no weather at all. Okay, so here we go. Yeah, rain, no rain. Sam's example here. So we say if we detect rain, we get rain. If we do not detect rain, we want no rain. But as he suggests there, the issue we're going to get is it's only going to have like 9 examples of no rain where there's fog, where it has a valid value of events and doesn't contain rain. But for all these NAs here, you're going to get 205 missings. Okay, so the way to do this, so it's something like make NA equal to false. So we could make it so this expression right here tests for and can try and find a NA. I'm actually not positive off the top of my head if it's going to like me doing that. So let's see what happens. Do you remember the function that returns a true if a value is missing? It's a way to test for NA values. There's a whole series of these functions for testing things. They are the is series of functions. If I say is dot There's a whole bunch of them. Something like is.array returns a true if it's an array. Is.call returns a true if it's a call. Is.na returns a true if the thing you give it is a missing thing. These are good to know about when you need to test something. Let's see what happens if I say is.na events. Now, what would I have to put between these? If I have, this is going to be a logical statement, and this is also a logical statement, and I want it to return a true if either one of them is true. What do I need to put between these things? Vertical bar. I like it. Vertical bar means or. So or literally means all I care about is if this is true or this is true. Let's see if this works. I'm actually not sure off the top of my head if it will, because I think often NAs tend to mess up your or statements, but not always. If we run this, let's run all the way over to rain, no rain. Okay. So you see what the issue was here. This is actually my fault because I just gave it the reverse of what I wanted to do. So if events is NA here, I had to assign rain. So that's actually not what I want. I wanted to assign no rain if it is an NA. So how could I flip this around here to make it so it will return no rain if it is missing? Otherwise not. There's a few different ways I can modify this. So what is the actual logical thing we want to be? Basically what we want it to be is anytime it is missing, it should be NA, or if it is not missing and it contains rain, it should be rain. Off the top of my head, this Boolean logic is getting complicated. NA if else, and then NA equals false. No. So the thing with this, what you've got here, that's actually would be a weird way of constructing this. We could also do multiple if statements, but I tend to try and avoid doing that. So the issue here, it's going to detect the rain here, but then it's thinking you're doing an assignment over here in the middle of an if else statement, and it's going to kind of get grumpy. What you could do is a two-stage process where we assign it, and then if it has an NA in it, we replace it with a like a no rain afterwards, which I'll show you how to do that in a second too. Well, this first one up here, this might work. I'm trying to remember my Booleans. I could say, if it is not missing, no, I don't want not missing. So it's if not missing and string detect, will that do the job? Yeah, that'll do the job. Okay, so here's a mind bend. What have I actually stated up here in this logical statement? So I'm saying the condition that must exist for the events column to produce rain is both of these things must be true. It must find the term rain, and it must not be NA. You're like, well, that makes perfect sense because it wouldn't even be able to perform this operation if the data were missing in the first place. You're like, why do I need both of those? It's because it's the other side of it. If events is NA, right? So if events is missing, this thing right here returns a false. This thing returns an NA. The NA and the false together join together to produce a false, which is stupid. So for instance, NA and false produces a false because it's missing. So if you and is essentially an addition for logical operators. Well, if you say nothing and false, well, the nothing contributes no information, it remains false. This is stupid shenanigans. So it's one way to do it, right? Okay, so we can do that. There's other options. There's a two-stage one, which will probably make more sense to most of you. Let's just go ahead and do the previous statement we had. So this is actually kind of based on this one from chat here. I'm going to say, okay, if else string detect events rain, let's call it rain. Otherwise, let's call it no rain. Okay. Well, then make rain equal to if else is .na rain, no rain, Otherwise, no, sorry, otherwise not quoted. Rain. This will produce an identical answer. This is a two-stage process. No rain, rain. So what this did first is create a rain column based on our logical, the illogical output of string detect. But anytime this event was NA, this had an NA in it. So I just went ahead and said is, well, I know every single NA is no rain. So then immediately I say, let's overwrite the rain column with if else rain is missing, replace it with no rain, otherwise do nothing to it. Two-stage process. Does that make sense? If you don't know how to do it in one step because it looks like this, and that doesn't make any sense to you, break it into more steps, okay? There's nothing wrong with creating a column using multiple sequential operations. Whatever works for you makes sense. So you can do something like that. Okay. Probably other funky ways to do it. I actually think that there's a way to do it with a single logical off of sort of a detection statement, but I think you'd have to use grepl to do that. Grepl Perl value false. Grepl, I'll use bytes fixed in our case. Yeah, I feel like there's some heinous thing I could do with grepl to make it return what I wanted to in one step, but I'm not positive, and you don't want to see it. So, okay. So does these make sense? Or do you have any questions about what I do here? Okay. Sometimes the logic is tough. Like you know exactly verbally how you want to do it, but it's a pain. Another thing you could have done is just replace all of the NAs in events with a non-missing value like space, and then the string detect would work. So you can also think about modifying your data in place or something, and it will work. Yeah. Always a solution. Sometimes think outside the box. Okay, so these are equivalent. I'm just going to go ahead and use this one because it makes more sense. I'm going to assign it back to weather data. And I'm going to look at weather data. Nice thing to do is if you create a column using data from another column, look at those two columns next to each other. I'm going to say count events and rain and make sure these things line up the way I expect them to. Fog should be no rain. NA should be no rain. Everything else should be rain. Okay, that looks pretty good to me. We don't seem to have made any gross mistakes. Yeah, so that looks like it works. Okay. Next one. Okay, so what we got here now, we have bike station region information, we have rainy weather information. What we want to do is merge these together. We want to take trips weather and join it to data list trip data, or sorry, we want to create trips weather by joining together trip data and weather data by the trip start date, just to add the rain column to the trip level data. Just the rain column, not the rest of it. Okay. So what we want to do here, right, is we just want to get one column out of our weather data and join it onto our trips data. And we're going to assign it to trips weather. So we aren't going to be working with an ugly list structure like this anymore. We're finally going to work with a normally structured data frame like we've been doing all term, finally. Okay. So first thing first. Okay. If I want to merge together my trip data and my weather data, what am I going to be merging on here? It says I'm by trip start date. Well, if I'm going to merge on trip start date, let's take a look at what the trip start date looks like. I'm going to say trip data. Take a quick glimpse. Okay. So what is the trip start date in here? Where do I get the trip start date? Is there a column that's just the date? No, there's no date column. So if I look at my weather data, and we'll see my weather data is, yeah, Sam's instinct there is what we're going to do. If I look at the weather data, right, it only has the date. It doesn't have like a time, so it only records the weather for the entire day. So what we're going to need to do in our trip data is we need to extract from start time and stop time. Sorry, actually, from just start time, we need to extract the date here. Okay, so let's get on that first. I'm going to take my trip data. So why don't we say create a new variable? Easiest thing to do is, okay, if I want a date in my data, make a new column. I'm going to say, let's mutate date. Okay. Now, this is one where the answer is incredibly easy for how to do this, but you only saw it once, so you might not remember. How do I get the date out of a date time object in R? Does anybody remember? I did it once in the lecture slides. So MDY would be really useful for converting text, but this is not text. This is already a date time object that already encodes calendar time and clock time simultaneously. There was a function I used on the police data that takes a date time object and turns it into just a date. How do you say take a numeric vector and turn it into a character vector in R? What is the function to do that? Do you remember? Anyone? As.character. So if you want something that is not presently a date to be a date, what do you think the function is to do that? Correct. It's as date. The weird thing about it is, for some reason, it's got a capital D in it. The reason for that, actually, it's not that strange. It's because the date class has capital D in it. That is the strange thing, that for some reason dates are capital D, and you can actually see it if we look at the weather data. Oh, sure, they don't show it here in the tidyverse. It's actually a capital D date object. If you extract the data type, it's a capital D. Yeah, so what we got to say here, and this is really it. As.date. What's the name of the column? It is start time. If I say as.date start time, I run it, scroll over to the end, it extracted the date. So date time objects, one of the reasons they're so nice and they're so powerful is they recognize special things like this. You could extract the date from it, but you could also extract weird stuff like what day of the week is it? What month is it? What quarter of the year is it? You know, is it, was it presently a leap year? You know, all kinds of stuff can be extracted from the objects. As.date is a simple one that just extracts the date information. Okay, well, that gives us a new date column. Okay, so now we have a common identifier. We have two columns, both named date, across our two different data frames. So here's a question. Problem with mutate input date. X character string is not in a standard unambiguous format. Input date is as.date.character time start time. So do this, glimpse trip data, and tell me what this says right there after start time. Probably says character, right? If it says character for you, then you got to go all the way back up to the stuff from the first half of the homeworks template, because something went wrong when we converted that to a date time object, because we did it all the way up here where we said assign to data list trip data, mutate across start time, stop time, MDYHM. This is what turned it into a date time object to begin with. So make sure this chunk up here, you might just want to, if this chunk is here and it looks like this, first make sure it is assigning it back to trip data. If it is doing that, you want to make sure to run all prior chunks. And if it's still not working, then you got some error somewhere with making your trip data. But this needs to be there. In this template, it's about line 96. If you're using your own one originally, you need to make sure this happened here with, yeah, the MDYHM call here. Do you not have that? This, of course, this code here is in the template that's on the website too. If you need to grab that code or something like that, I can also just literally, if you need to go all the way up there and add this code to, that's the code right there. If you just needed that chunk back up there, we did it after the gender section. So when we fixed the gender variable, we also did it for the weather data. We converted it to a date for weather data. Same deal. Have you found that in there? Does it look fine? If it does, yeah, it's okay. Great. Okay. So let me go back down here. So now we've got a date column and trip data. I haven't actually assigned trip data back. I'm not worrying about it yet, but we have a date column in it we can use to join our data together. Okay. The next thing, right, is we want the weather data, but what do we actually need in the weather data, right? Out of all these columns here, what do we actually care about, right? What is the minimum information we need from here if we want to get what we care about out of here, right? We only care about whether it's raining or not, right? Well, we need that rain column, right? Now, if we want to join this weather data onto our other data, what is the other thing we need, right? We'll need one other piece of information. All this other stuff is useless to us. The only thing we need, right, is date, okay? So what I'm gonna do here, there's two ways I could go about this. This is the way I like to do it. If I want to join two data frames together, what do I usually just do? Like when in doubt, especially if I know I want all the data from this first data frame and I just want the matches from the other one. How do I join two data frames together when I want to keep everything here? What function am I going to use? It's like 8 of these things. Select no, but we will use select here in a second. Left join is what I'm after. So left join says I got a data frame on the left side. So the data frame on the left side is trip data with the date column added. The right side is going to be our weather data. But what I can do here is I can say, use the weather data. And this might be what you actually meant. You probably actually meant this was to say, take the weather data, and then if I only want 2 columns out of it, then I select, right? And I'm saying I want, right? I just care about the date and I just care about the rain, okay? So the way this is working is probably to your eye, quite possibly a little convoluted. So I'm saying here, take this data frame, add a date column to it, pipe it into left join. So the first argument to left join is this data set on the left side. Oddly enough, the second argument to left join is my weather data and select to date and rain. So the second argument to left join is just these 2 columns of the weather data. So I did my selection inside of my left join. It runs this code inside the left join first and then performs the join. This saves me from creating another intervening object because, as I have often repeatedly said in this class, I will do almost anything to add anything to my global environment because I'm obsessive. For instance, you can see across this entire lecture we're doing, I've only created so far a few values in here. In fact, I'm annoyed by how many of them there are. Okay. So this will join our stuff together. Can't join on date because of incompatible types. X is type date is type character. So this is again, so what you have here is you haven't converted the weather data's date column into a date. So again, back up on the prior homework section, if we scroll up, you probably don't have this one right here, or it didn't run. So make sure you've got this one here, which will take the weather data's date column and convert it using MDY because it's text to begin with. Make sure that's up there, rerun from there, and you should be fixed. I don't know if I just breezed through that too fast on last lab if it got missed, because that's looks like a couple of you missed that. Yeah. So, sorry to confirm, is R just automatically identifying which variable it's using to join? Yes. So the nice thing about using uniform naming schemes for things is if you want to do joins, Well, if you know your thing you want to join on are the only two columns sharing the name across them, it takes care of it for you. You could be specific if you want. I could say here, I equals date, and that would make it absolutely certain. But it's going to be the same result. The only column they share between the two of them is date. Next thing, how do we know that the rows of the columns are in the same order? Is there a way to list code and have it not run? Well, if it's commented out, or if your chunk is turned off. So if your chunk has eval equals false. So are you saying you have your code creating the date up there, but it's not running? Is that your issue?
No, sorry. I'm trying to run from the top because I have the date at the top, but I've just been running each section, so I don't think it's running the top part. But I've been copying down all the different options of ways to do things.
Oh, I see.
And so I want to like rather than removing chunks of the different ways to do it, just like get it to not run. But you said if I create a chunk and just put eval equals false.
Yeah, if they're in a chunk with eval equals false, or you could comment them out, so you could like highlight something and hit Control Shift C and comment out whatever you're highlighting, or just add a pound sign hashtag for the kids on the left side. You could do that. That's a couple of things, but you could also do this, like, you could say eval equals false will just run nothing inside the chunk. I typically just comment stuff out, or I put it in another chunk, and then say like, you could add a chunk here, and another thing you could actually do is do that and write the code in here and just treat it as text, so it's no longer actually a code chunk. Yeah.
Thank you.
That's good though. Yeah, adding in those sort of extra ones so you know other ways to do it it's good practice. I do that kind of crap all the time in my stuff. I'm like, well, I know 3 ways to do this. I'm going to put them all down there so I remember them in case I need them. Okay, so we've joined this together here. And did I answer the kind of question, how do we know the rows of the columns are in the same order, that things matched up? You can run tests is one way to do it. You could create some sort of unit test that would allow you to verify things are lining up correctly. Otherwise, it's sort of on faith that the computer does it correctly, that's not getting weird duplicates and stuff. One thing to check is to make sure the number of rows are correct. So the trip data here, right, has 142,846 rows. If we know the way joins work is if there's multiple joins, like if there's, so if we join on date, but there's a duplicate of date, it should duplicate the rows on that date too. Well, we would really hope this is 142,846 rows like 2, so that means there's no duplicates. If I do this left join 142,846, that looks pretty good. Another thing I could do is, well, what happens if maybe there's some days missing or some dates missing? If I swap to an inner join, we would hope it's the same length. So that means the inner join would be, if anything fails to match from the left side, it would be deleted from the data. It's still the same length. So the inner join, the left join, and the right join should be equivalent. One more added. Uh-oh. Why would the right join gain exactly 1 row, do you think? I'll paste that code here 1 second. So if I right join the weather data on, it adds 1 row. Because if I look at the length of the weather data, it's not 1 year data. It's 366 days of data. It has 1 additional day that's not found in the trip data because it's a data quality issue. So, you can do your own little verifications. Inner join and left join are equivalent. I'll do both. Let me get the rain data for you. Cost the code from the chunk about changing rain. No rain, please. Get near the rain column doesn't exist. Yeah, let me do this. Let me get that. Yoink. Have this code in it, weather data counts. I have it in mind just as a check. I like to, anytime I create a variable or something, do a quick tabulation to make sure stuff looks okay. So I got it right here. Tabulation. Got that error, then I removed it. Well, if that didn't work, you have a problem because it means you either don't have events or don't have the rain column. So you want to make sure that you have that this did run, because that error should only pop if you don't have basically don't have the rain column. I want to verify that. Yeah, this is sort of a foolproof line of code here. There's really nothing that should make that fail to run. Is it working now?
Yeah, I think it's good now. Thanks.
Sweet. Okay. Here, data list if else. It's the code I use for rain. Yes. So the reason that you get that error there here, right, is your code is actually completely correct, but you're not assigning the result of it back to the original data. So if you augment that and just add this right here, it's going to work perfectly fine. So basically, you essentially just have this section right here. Well, technically, you have just this one right here. Yeah. Probably one of the most common mistakes I make, and it's actually one of the reasons I do. I try and create as few objects as possible because I inevitably forget to create the objects that I need for things. So I usually just err on the side of never creating any objects in my environment, so I don't run into these problems. Do the entire operation in one pipe chain or something like that. Okay, so gonna go down here. Okay, so we've correctly, it looks like, joined our stuff together. Now, after I've made sure it works, is when I'm going to add my assignment. I'm going to say, okay, name this thing trips weather. Make sure to assign it. Take a quick glimpse at it. Trips weather. And it should be our trips data plus a rain column. Otherwise, the same as our old, basically our trip data. But the one really nice thing about it is it's not in a list anymore. So I can leave lists behind because they're dumb. Okay. Actually tremendously powerful and useful, but also dumb because they suck to work with. So, well, that's actually so long. They suck for you, for all of you to work with. I have lots of lists inside my things and I love them because they're very, very powerful. But explaining sometimes what's going on with them is horrific. Yeah. We're actually going to spend a bunch of time with list columns on Wednesday. You won't realize they're list columns because they're embedded geographical data, but it turns out they're list columns. If you open them up, they're terrifying. Okay, so next thing we want to do, that all working right? Nobody's having any weird residual issues. So now it says, now for the grand finale. The grand finale is to write a function we're going to call daily rain rise. This is going to be a function that takes two inputs. It's going to take a region code like CBD or UW and a direction indicating whether we're thinking of trips going from that region or to that region. But then inside the function, it is going to do all of these things. What it's going to do is it's going to take our trips weather data. It's going to filter it down to trips that came from stations with the region code we're using or went to stations with that region code. So it's going to do two different things depending on whether the direction is from or to, and then it's going to use the region code on that. So for example, if I say region code is BT and direction is from, it's going to filter the data down to the rows for cases where the from station region is equal to BT. Okay. Then it's going to use that to make a data frame we're going to call temp DF, which is going to be one row per day, counting how many trips there were in that region code going that direction. This is going to have a starting date, how many trips there were, and whether it was raining or not, using group by and summarize. Okay. Then we're going to generate a plot, a scatter plot with the trip starting date on the horizontal axis, that's the x-axis, and then the number of trips on the vertical axis with points colored black for days with no rain, deep sky blue for days with rain. Add a nice legend to it, make it look nice, and make it correctly change the titles and labels in the plot based on our to station, or like either to or from station and the station we're going to or from. Okay, and it should spit out a ggplot when it runs. That's a lot of action. Okay, so let's make it work. So first of all, we can break this up and do it in kind of steps. So what I'm going to do here is we've got a skeleton for this function here like this. Okay, so the first step we want to do, I'm going to break this out. You can kind of see these are separate operations. Okay, so if I wanted to say, make this function, just take my trips weather data and filter it down so we can say either to or from and pick a region code. How might I go about doing that? So let's just assume for now, let's assume I only care about the region code. So let's say we're going to assume every ride is 2. How could I filter my data inside this function so that I could select a region code and have it give me the collect region of data, but only for 2 directions? So we're always going to use the same data. These data are trips, weather. So if I want just the rows, let's just say for now, it's the CBD region and it's going to it. What would be the code to filter down to my region is CBD, my direction is 2? Well, what's the data look like? Okay. So is the to station region and the from station region, where is all this data located? If I want to say that we want to filter down to the data specifically rides going to CBD, where is that information found? What column contains rides going to CBD as a signifier? To station ID. Well, specifically to station region for us is going to be just the CBD, but same idea. Well, yeah, but where's the data for the from station region? Well, it's in a different column, right? Well, if we want to search a different column based on the direction, can you think how we might want to do that? How would you write a statement up here that would search for to station equals CBD? What would my filter statement be to make it my to station region is CBD? So we're going to use filter because we're going for rows. So if I want my to station region to be CBD, what would be the exact statement I would put in here as a logical statement? I mean, it's literally exactly what I just said, right? What's the logical test? So we're going to see this is going to turn into a mind bender with a surprisingly simple solution in a minute. So if I want to limit it to rides going to CBD, what one logical statement would I have to include? It's a simple equals equals statement. Do we have a guess? Yeah, you're dead on right. So if we want to filter down to rides going to CBD, we say to station region CBD. If I actually run this, like I put in my console as an example, we'll see immediately all of these rides will actually cut off the relevant. Let's do it here. To station region CBD. If I look over here, you'll see every single one of the 2 station regions is CBD, but they're coming from all sorts of different stations. So this statement works. Okay, so this is, right, how would I make this flexible so I could go to any station region in this function? So instead of specifying only CBD, what, based on my function arguments here, would I have to change to make it so I can adjust which station region I'm getting? Got to change one thing. We're still focusing only on to station region. I don't care about directions yet. How do I make this flexible for any region code? Exactly. Use region code instead of CBD. If I say region code, I could literally run this function now. Daily rain rides. If I run daily rain rides CBD, daily rain rides CBD will give me only rides going to CBD. This lame looking little function already works for getting 2 stations. Okay, so as long as I don't need to specify 2 stations, it works. Okay, now here's the thing. So this works perfectly fine for getting the ones going to a particular station. What do I have to do if I want this to work for either direction? So where in here am I specifying the direction we're going?
Can I ask a question?
Yeah.
This is more of a technical art thing. Is there a way that you can run all the stuff above and like keep that, or do you have to just run the entire? Because every time I try to run like something within this chunk, it's saying that it doesn't exist because I haven't ran the chunks above it.
What does it say exactly?
Like when I tried to run it, it said like trips weather not found.
Mhm.
Because we created trips weather previously. And then when I was doing that, every time I tried to like do the left join, it kept saying the date as character because it wasn't running the stuff above when we changed the date to character. So I'm finding that I have to like run the entire chunk every single time.
That's odd. You should be able to just right now press run all chunks above, and it should return you to a state at which all of that stuff works properly. So if you run every chunk above, trips weather should plus weather. Trips weather should exist for you. Is that not true?
If I run it all above, yes. But then like if I do another code or something like that, it makes me rerun everything from above.
So what exactly, like doing what exactly makes it have to rerun? Because it should, everything should stay in the environment. You shouldn't lose anything.
The issue is not staying in the environment because each time I've ran like the entire trunk like 4 times at this point. And then like I try to do it and then it's like trips weather doesn't exist. So it's making me each time. I don't know why it's not saving in the environment.
So having pressed this button here right now, trips weather exists, like in your environment. So you just ran this and then trips weather exists while you're in this chunk, but it at some point it disappears.
It's let's see. I'm running the whole thing. Feel like it's stopping at some point. Okay, it's having the issue with the date again.
Okay.
I don't know.
So make sure the assignments are there back up at the higher one. So most likely, I mean, there's basically most likely what's occurring is that there's some bug in one of these chunks up here, and it's not so much that things aren't like being created or being deleted, but something is not being created when you first run through it, and you're kind of going back up and running one section of it that makes it work. But there's like a error, like one of the chunks probably has some like one bad line of code that's making that one chunk not run for you, and so we have to track it down. So it could be in anywhere in the document essentially, which is sort of the thing. So because if you press this button and run it, it's not going to stop when errors occur. If you want to find where the error is, if you press knit, it will probably stop the document when it runs into an error and tell you where that error is.
Okay. I'll try that and I'll just put it in the chat.
Yeah, let me know. And then let me go down here. And then if it keeps being like stubborn, feel free to absolutely like send me the R&D and we'll track it. I'll probably be able to track it down real fast. Okay, so what was this thing? Neff says my trips weather exists, but it's 36 columns, not 16. Why might that be? Because he didn't filter your weather data down. So here in the inner join, I said data list, weather data, and then select only date and rain. I cut off all those additional weather columns. And so there are, there are how many in weather data? There are 22 columns in here. So the reason that it would be approximately 20 longer is the date column is joined on, and then it tacks on another 20-ish columns. That's probably what. So here, got a, maybe when we did 2 examples, it was assigned both times, only one was changed. That could also be it. That's another one is if you go up to the date one all the way up here. I may have done it 2 different ways and it's being assigned like on both of them, but the one that's not working or something. That could be the potential case. Next one is from this filter X station 2 station region not found. RLAN West error occurred. Okay, let me see. So you're saying here, you're getting a X object two station region not found. Input dot one is two station region equals region code. Do you have exactly this? And when it says I select only two columns remain, it's because your select is probably in the wrong place. You'll notice the select is actually inside of the inner join after weather data rather than outside of it. So it should look something like this. Because we're actually subsetting just the weather data here, and then it's spitting out, and you should have 16. If that makes sense. Okay. Yeah, so this is just an example here. If I wanted to make it, so basically what I was asking earlier, where in this filter statement here does it signify whether it's the to station region or the from station region? We're not actually specifying it exactly, right? What would you have to change to make this work for the from station region instead? So if I want to make this so this whole thing would get daily rain rides from going from CBD rather than to, yeah, I would have to change to station region to from station region. Have you ever seen me perform an operation in like a filter statement where the thing on the left side of the equality is flexible? No, you probably haven't, because it's fucking weird, right? It's not the kind of thing that one normally does. So the issue here is, what would we have to do, right? Like I asked, we would have to make this be instead from station region if we wanted the direction to be from. Well, what's a way to make it so a function or say a loop or something like that runs this code when the direction is to, and instead runs this code when the direction is from? So let's cheat. Let's not worry about changing the code at all. Let's just make it run two different sets of code depending on what's going on. Do you remember how to do that? Week 7. It's a thing called flow control. I only spent a little bit of time on it. So if you want to make it so something happens, if you run if one logical statement is true, but it does something else instead, if there's a logical statement is false, remember how to do that? Do you remember my stupid example with counting whether numbers are divisible by 2 or 3? We ran through a whole tree of options. Remember those types of statements are. They have a very plain language sounding thing, very common word. So if I want it to do one thing in one case, else do something in another case, I can say literally exactly that. If the direction equals to do this thing, else if the direction is equal to from do the other thing. Okay. When you can't figure out what seems to be an elegant solution to a problem, that you're just like, God, it really just seems like I need to be able to run two completely different lines of code depending on something. Do that. Write both lines of code, but have them select which one it activates. So the basic idea with this function here is now I have to provide a direction. I'm going to have to say like direction equals to, and make it clear here that I'm doing region code equals CBD. If I run this function here, if I then do daily rain ride CBD direction 2, I scroll on over here, my 2 station IDs are all CBD, my froms are PS. If I change this to from, now my from station IDs are all CBDs. Okay. I've now created a function that selectively switches between two different filtering operations by just writing them both. This is one of the useful things for if-else statements. If you can't figure out like a more elegant way to do it both ways and have it swap between them. Okay, so we now have a function here that gives me the data I want. So everything else we're going to do inside this function is going to use one of these two little data frames. It's either going to use the data filtered down so the to station region goes to a particular region code. I'm going to clean up some of this code, or it filters down to the from station region is equal to the region code. Okay, so I'm just going to call this, let's call it, assign it to tempdf here. So what this is going to do is inside the function, when it runs, it's going to assign a little temporary data frame in here, and then we're going to do some magic with it after that. Okay, so we essentially did this. It filters the data down to trips that come from stations with that region code or went to stations with that region code. Okay, the next thing I want to do, it says, is make a data frame called tempdf with 1 row per day, counting how many trips were in region code going that particular direction. Okay, well, we've already done half of this. We already have it set to the particular region code going the particular direction. So that means all we have left to do is get 1 row per day counting how many trips there were. Okay, so the other thing though is we also want to know whether it was raining or not that day. Okay, so if I got my temporary data frame here, which is just my filtered down data, it honestly looks exactly like this right here. How would I take this, for instance, 16,794 rows, and instead get a data frame that contains only a count of the number of rows there are per day and per whether it was raining or not? Do you remember how to do that? So if I got this temporary data frame, contains all these columns here, and I want to aggregate my data by the date, how would I do that? I just want to count the number of rows there are by date. What's the function to do that? Shit, I used it like 4 times today already. It's quite descriptive. If you want to count how many rows there are by some variable, it is count. You can literally just say, count the number of rows in the data. If I say tempdf count by date, I'm going to rerun this function code here. Okay, daily run rides CBD direction from. My output is now 1 row per date in the data and the number of rows that were in it. Well, a single row is a single ride. This counts the number of rides there were on each individual date. That is how easy that aggregation is to do. But I lost one thing I also care about. I also care about whether or not it was raining. So I say here you'll need to use group by and summarize, but I'm actually showing you a shortcut. Count is a shortcut for group by that variable, summarize n equals count the number of rows. Well, if I also want to get whether it's raining or not, what do you think I have to do to modify this? Just intuitively, if I also wanted my aggregation to have the rain column, what would I need to do? Like first thing your mind would say. You're probably going to be right. Yes, just add rain. I want rain, let's add rain. Okay. If I run this function, now it has a date and a rain column. So the reason that works is because it's grouping on date and it's grouping on rain and counting them, but the rain is actually date level data. So it's exactly the same within all observations of a given date. This actually just ends up propagating the rain column to the dates. It doesn't create multiple rows per date per rain status. There's only 1 per one. This is a trick where you can get the exact same aggregation and also keep a column as long as that column is invariant across all observations of the first grouping term. That's a complicated thing. but the intuition, if that's the thing you think about, is absolutely correct. You want the rain, add it to count. So now we have a function that spits out a date, whether it's raining or not, the number of observations as n. Okay. Well, you know what the cool thing is? That is all of the data stuff in this function. That's ready to plot. The thing we want to plot is the date on the x-axis, the number of rides on the y-axis, and whether or not it was raining is going to be a color. Okay. So the next thing we want to do, right? We want to assign this to a thing called tempdf. I'm just going to say, let's overwrite tempdf with that. The next thing, okay, use tempdf to make a ggplot scatter plot that is g on point with trip on the x-axis, the count on the y-axis, color some points. What is the syntax to use tempdf here to make a ggplot scatter plot? What do I got to do here? It might be in a function here, but we don't actually have to make it flexible in any way. This plot is going to be exactly the same for every status we're working with. Well, almost. It has to be flexible in its titles and stuff. We've already taken care of the data. So what do I got to mean? What does all ggplots start with? ggplot. Plot and data. What's the data? We've already created the data ourselves inside the function, right? It's not actually daily rain rides. Daily rain rides is the name of the function, but what's the data we're working with inside of daily rain rides? Yeah, it's tempdf. So we've basically created this temporary data frame here. I stuff it in this ggplot. How do I make a scatter plot? Take it. I know what you meant. G on point. If I wanted to make this as particular, my aesthetics be date on the x-axis, the count of rides on the y-axis, what do I got to add in here? Yeah. We need an aesthetic. We need the x to be the date, the y to be the n, the count. But there's one other thing we want, right? If we want it to be colored by whether it's raining or not, what do I got to add? Not being sneaky here. That's right. Our data look like this. Yep. Well, we could use fill. Fill would be slightly different. So fill doesn't like usually play nicely with G on point unless you use a particular point that has a fill aesthetic. Typically speaking, we would use color, probably. Color rain. I can actually write these out and specify where this is all going just to be clear. Color equals rain. Fill would depend on what else I use. So some G on points can actually use a fill aesthetic. Okay, so just as an example, if I run this function and I say daily rain rides CBD and from, this is a scatter plot of the date across the year and then the number of rides on that particular date. And it's colored by whether it was raining or not raining. As you can see, there's more rain, of course, through this time period of the year. There's less over here. There's a few big spike days here for some particular reason. Okay. Well, now we can dynamically generate plots though. So notice I could say, well, let's instead look at rides going to the CBD. That's rides going to the CBD. Let's look at rides going to Belltown. That's rides going to Belltown from Belltown. Okay. Well, you just created a dashboard style flexible plot that you can use for any station in any direction inside your data. Took a little bit of work here, but it's already really powerful. If you want to be able to see anything going on in this data set, you swap one quick little argument, You've done the hard stuff. Now the function is super flexible and easy to use. So let's add a couple other things to this. Let's dress this up a little bit. Okay, so this plot is kind of ugly. What we want to do here is let's make it so, let's say, I'll just show you this. Let's say if the Y label is number of rides. But let's say we want to do something like, how would we make this? Oh, actually, the first thing, I specify up here because I'm annoying that I want it to be deep sky blue for days with rain and black for days with no rain. Do you remember how to manually set colors in ggplot? Remember what the function for that is? How do you set how all things map to aesthetics? There's an entire class of functions for doing this. Remember what they are? If you want to control colors, if you want to control how numbers look, if you want to change something to be logarithmic or square root or something like that, anything you want to alter how something looks, what is that entire class of functions called? Not quite theme. Theme changes the overall look at the plot, but like say for one axis. So if I wanted to make it so the x-axis was like logged, or I wanted to make it so, say I manually control color. Do you remember what these are? Do you remember scales? There are so many scales. So in this case, I'm going to say, I'm going to adjust the scale for the color aesthetic. And the way I want to do it is to just set my values manually. To do that, I'm going to say my manual values. Well, first I'm going to say, let's name the color scale to be weather. So instead of being rain, I'm just going to call it weather. And my values are going to be equal to, let's say, rain equals, rain, is rain blue or is the other way around? Rain is deep sky blue for rain. So let's make no rain equal to black and make rain equal to deep sky blue. Okay. Let's run this function, make sure I don't screw anything up. Now we have deep sky blue rain dots, black no rain dots. I've manually adjusted my scale values, and now it says number of rides over here. There's one more complicated thing we want to do. So if I want to make it so when I get region code BT and direction from, it says daily rides going from BT. If I wanted to make it dynamically create this text for my title, do we have an idea what I would need to put in GG title? So GG title, you give it a title. So if we've got something like daily rain rides going from BT, what needs to be flexible here based on the inputs of my function? There's two things that need to change, right? Or you can think about the other way, what needs to stay the same? So if this was instead CBD and 2, what's got to change? Yeah, daily rides going from region code is the first step. So how would we make it so that instead of BT being fixed text here, it's dynamic text that updates to whatever the argument from our function is, right? So I can just delete this, maybe leave a space there. What do? How do I make it tack on that direction? So you're on a sort of on the right track with region code, but all this then needs to be inside something else. How do we normally staple together a bunch of text? What is Chuck's favorite lazy function? How do you usually stick two pieces of text together? Backticks. Backticks if it was an object name, but there's a function specifically for putting text together. Remember what that is? We used it a bunch. Yeah, paste and also paste 0. I'm going to use paste 0 here, just because I'm going to manually type my own spaces. Okay, so this is now flexible for the region code. If I say daily rain rides, yes, CBD2, it now says daily rides going from CBD, which is problematic because it's actually direction to, not direction from. So right, instead of saying from here, delete that and say direction, add a space because we need the space there. And now it says daily rain rides going, whoops, 2 commas, daily rain rides going to space CBD. And if I run it, make sure I didn't make an error. Daily rides going to CBD. I could instead say, let's look at going from South Lake Union. Daily rides going from South Lake Union with a number of rides, the date here, the weather it was at. And there you go. That's basically, we've made a little function. If you wanted to, you could dress it up. Use something like geom smooth. Oops, sorry, run it from up here. Geom smooth. And now we could add some like smooth lines in here that'll dynamically update the sort of average trend in rides over time and stuff. Dress it up how you see fit if you want to. We could even split it down with like, give it a minimal theme. That's a little bit simpler. Okay, so don't need any of this crap. And you're just going to do a couple examples of this. So do something like CBD2 and then something like, you know, BT from. Okay, my plot isn't running. When I try to run daily rain rides, it tells me temp df doesn't exist. I got an idea what that might be, but can you copy just the whole brick of crap into chat? And I will copy it back into here and diagnose it. It's probably this line right here. Okay, I got that. Okay, so you got all this. Temp df trips weather filter trips weather. Yeah, there it is. So you don't have an assignment operator right here, so that anytime the region code is from, it wasn't assigning and creating temp df, which would create a weird error because it would work when you have it set to 2, but fail when you set it to from. So you got that line right there. Otherwise, that looks good. So if I run your daily rain rides, it works. So it says 213 rows containing missing values on the GM point for rain, because you have a capital R here for rain and the actual value is lowercase r. Change that to a lowercase r. Run the whole thing. And now it works. So did you see both the things that I changed? Yeah, so if you used capital R, then keep it that way. But yeah, it was just mainly this one right here, that assignment. Did you get that? Any other errors from anybody? Two station region isn't found. So if you're getting two station region isn't found, then you got to look in your trips weather data and make sure your trips weather data looks like this. So if I glimpse at trips weather, it should have a two station region and from station region. If it says it can't find trips weather, then your issue is probably up here. So what does that look like?
Yeah, I think the error is up there because I only have 14 columns instead of 16.
It's probably on that join right here then, because that's probably, well, 14 instead of 16. Two less. Oh, that's curious. So are you missing just you're missing rain, but what else are you missing? That's curious.
Yeah, I'm not sure, but it does like it looks like from station name to station name and rate are there.
But is it to station region and from station region?
No, yeah, okay, yeah. So those are what's missing.
Okay, so probably up here where we did the region extraction, did you assign it back to the trip data?
No, I think that is the problem.
Makes sense. That'll do it. So same in place for cassette here. Mine keeps saying to from station region isn't found. That's created up here at, in mine anyway, 141 to 143. So make sure that you've done the region extraction on these and assigned the trip data back to the data list. Might be the exact same error. Okay, and of course, we got to the end of it there. So if you're not having any errors, feel free to chat. I'll see folks on Wednesday. If you are, feel free to keep in here and I'll troubleshoot until we get everybody's up to spec and running. Or if it's late and you don't want to be trapped in the lab with me anymore, you can also leave and send me an email with your R&D attached and I'll figure it out. Okay. Still trying to change the date. For the date one, you ought to just use this code right here. So this is what I was using, like that. So MDY. At least for the weather data. Okay.
I'm gonna try that and then I'm gonna try to run. I didn't want to interrupt, so I'm gonna try that and then I'm gonna try to run from the top to bottom and see if it finally worked. But
Yeah, let me know.
The error was that I hadn't changed the date in the weather data. I only did it in the trip data.
Yeah, yeah, and if you keep having some little like kind of sneaky ones that don't seem to be going away, easiest thing might be to send the RMD to me, and then I'll just go through and I'll find anything in it, and it'll be really fast. So it's like I can glance through that thing super quick and just be like, well, it's probably just because it might be one sneaky little line somewhere that's giving you some grief. Okay, anything else? Things working, not working. I guess this is technically supposed to be like. Oh, shit. Good stuff. Oh, I guess this one is even mine. There we go. Okay. That working for you so far?
Can you hear me? My internet is.
I can hear it.
I'm still figuring out. Hi, I'm back. Because I saved my stuff in iCloud because I have a MacBook Air. It did the thing where it undownloaded the data again, so I had to download that, and for some reason that decides to kick me out of Zoom when it does.
God.
So I'm running from top to bottom now, and let's see. I think it all worked.
Sweet.
I think, let me. try and. Okay, I think everything's working, but the last piece and saying trips weather not found. Is that
Trips
old?
weather not found. So if trips weather is not found, go here to this chunk here, kind of where it gets created. And make sure the assignment is happening here.
Okay, that's the. Sorry, I'm just trying to figure out
Oh, you're
which
good.
select. No, that's not. Okay, wait. Trips data, trips weather. Trips weather, yes.
Then you can glimpse and make sure you can see it right here. And then it has the date and rain columns in it. Should have this many rows, this many columns.
Okay, yeah, yeah, column 16, rows 142,000.
And it has
Okay.
the rain column. Oh, it has the rain column for sure, but it's not many columns. Okay, so that looks good. So then you go down here. And if you like run this function and then you run a command for it, like any one of these, do you still get an error about trips weather?
I'm okay. The last thing that we created, right, with the plot.
Yeah.
I did not get an error, but I'm not seeing any plots show up.
Okay. So look at your function right here.
Oh, you know what? I have to load ggplot.
Yeah, it could be the thing. It might be kicking you an error for that. I loaded it way up at the top earlier. So
Okay, I loaded ggplot too, and still no plot came. It just like reiterates the code in the console.
oh, are you running running it like this? So you're doing daily raid rides, like region code equals this, direction equals this. You run it like that.
Oh, you're right. I'm actually just running.
Running
Okay.
the name, yeah. And that's what it'll do. You know, if you run just the name like daily raid rides, it's just gonna print that
Okay.
the code in the console.
So I did the daily rain rise region code equals CBD direction equals from, and I'm getting object temp df not found.
Okay, well, that's easy.
What else got?
Yeah, it's gonna be one of these things. It's either there's not an assignment here, or here, or here. It's probably this one.
It's taking a little while for the screen to update, so I'm right now still seeing the plot. So just
Okay.
okay. So there's 3 spots.
It's mainly one of these two. There should be an assignment from trips weather. It filters down and you assign temp df.
Oh no, I did not have that.
Yep,
Okay.
just miss one of those.
So temp underscore df.
That's probably what it is.
So that's that. Then that goes to trips weather, and then there was a second one.
This one is probably fine, but you have to
Yeah.
take temp df count and reassign it to temp df and then just kind of overwrite it.
I have that one.
Then you're probably good. Now rerun the function. So you have to make sure to run all this code, right? So the function reruns and then go down to one of these and you should have a plot pop out or a new error. We'll see what happens.
Okay, now let's run that. And then this bottom one again. Now I'm getting, okay. Now it's saying rain not found.
Ah, okay. Rain not found. So make sure that you have here. Is my screen updated? So you can see temp df and then count date rain. So this line should look like this.
I have temp df, and then there's the pipe count. Oh, okay. Rain.
Yeah.
Okay. All right, let's try this one more time.
Yeah, should be good. So you just spiral in on it.
Unknown color name, deep sky blue. Oh, I think I've added an E in sky.
Yep.
Okay, one last time.
You got it.
We did it.
Yes,
Okay, thank you so much.
absolutely. And if it gives you any more grief, shoot a message or a Slack channel thing and I'll get on it.
Thank you.
Cool. Have a good day. Yeah.